Hey, my name is Antti Karjalainen, and I'm going to present a talk about the open source stack for RPA. I'm the CEO and co-founder of a company called RoboCon, where we build tools and technology for creating and operating software robots that are based on open source technology like Robot Framework, and also on the board of the Robot Framework Foundation. So in this talk, we're going to first go through why we need an open source stack for RPA in the first place. Then we're going to introduce a tool called RCC. That's one of the foundational blocks of this stack. Then we're going to show how you can create and share a robot with the open source stack in just under a minute. And then lastly, we're going to go through some of the application areas of the open source RPA stack. But before we go there, I'm going to take you a year back in the world of open source RPA. And in RoboCon 2020, I described the world of Robot Framework RPA as a loosely coupled collection of projects, tools, methods, and ways of working. This is me on the conference stage presenting, and I'm asking the audience, what do they think? Whether we have a solution at our hands that's like a plane, ready to fly, ready to go, just hop on and use it, or is it something that's more of a instruction manual, nuts and bolts, and a roll of sheet metal? And the audience agreed with me back then that we were at a stage where we are more on the instruction manual side than somewhere where we have a ready plane to fly. Obviously, we want to get into a stage where we have a plane, which is the open source RPA stack that will be ready to fly. At the same conference, I highlighted that Robot Framework alone isn't just enough to make this happen. And we need more infrastructure around the project to actually make it something that's easy for people to pick up and start building on. And at RoboCorp, we set out ourselves to improve the open source landscape for developer tools and developer experience around Robot Framework. So with that said, a year ago, if I would have said that I want to create a new robot with Robot Framework, what should I have done back then? So firstly, we start by writing a task. That's plain and simple. Everyone can do that. At least everyone listening to this conference should know how to automate a task with Robot Framework. You write the task description, keywords, put it all together. That's fine. Nothing to it. But then when you need to actually figure out how to run it, this is something that I used to have myself for every project, basically. I used to have a set of scripts to run it on my Mac, on Windows, requirements files, and virtual environment management, WebDriver managers, and so forth and so forth. This is something that everyone probably has in their developer folder or somewhere, and they probably copy-paste it over each time they start a new project. But what happens when you actually need to share this to somebody else and expect other people to run it as well? Well, it really breaks down. It's not something that would have common conventions around or something that everyone would know how to do. So, we figured out at RoboCorp that there has to be a better way. We had some solutions that we needed to create, which needed a solution for this particular problem. How do we define a robot, and how do we configure it, and how do we manage them? So we created what we now call the open source stack for RPA, which is based on Python, Robot Framework, and a few other projects that I'm going to describe here in this talk. So we had a few principles in mind when we set out to do this. Firstly, we wanted to simplify and streamline RPA development process and provide a standard template for software robots that are built with Robot Framework. And second, we wanted to enable anyone out there to share and distribute robots seamlessly. So starting from the base, Python, Robot Framework, and automation libraries, there's nothing really anything more to it. That's something that everyone knows how to do already today. But going up the stack, we have a robot definition and configuration format in the form of robot YAML file. And on the top of the stack, we have a tool chain for creating, running, and distributing robots called RCC. And we're going to look more closely into this now. So RCC, really, when you understand what it does, it's a cryptically named project for first. It used to stand for RoboCop command line, but it's become much more than that, and we decided to open source it because of that, and just seeing how much it can solve for other people's. So it's a single executable file written in Go. It can be installed anywhere. It doesn't really require any prerequisite. It doesn't even require a Python installation in place. It's a command line tool that allows you to build command chains. So you can chain together commands in CI workflows and in your terminal, or you can even build other tools on top of it, like we're going to show you in a moment's time. RCC is fundamentally something that allows you to create, run, distribute projects that work seamlessly and can operate in an isolated environment so that they don't pollute your whole system, Python, for instance, when you run them. It's licensed under Apache 2.0, and you can find the code project under GitHub/Robocop/RCC. And on top of the basic features that are listed here, RCC comes with some cool caching features and some features that are still in our pipeline in development. So let's try that again. So I want to create a new robot by using RCC. The first step, really the zero step, is to install RCC. In this case, I'm using Brew to install it on my Mac. But if you go to the GitHub repo, you're going to be able to find instructions how to install it on Windows and Linux as well. And step one is to start by creating a new project with RCC. Here, I'm typing on my terminal RCC create, which prompts me to give the name of the project. I'm choosing the default, my first robot. Then it asks what kind of template I want to use. I choose the standard template here. And then I can just cd into this file. I see that I have three files there: conda YAML, robot YAML, and task.robot. And I'm going to open my Visual Studio Code. So here, looking at the files, I'm not going to go through these in detail. That will be a topic for another talk. But we have a robot file that's for the robot code. Then we have a conda YAML file that's for dependencies. Here, if you look, you see that we have dependencies in both conda packages and in pip as well. And in robot YAML, we have the robot configuration where you define how you run the robot, what kind of dependency file it uses, where does it output is results, and so on and so on. This is a standard, simple way to define a Robot Framework project that doesn't depend on external scripts and doesn't have to be invented every time when you need to start a project. And if you look carefully, you see that this allows you to mix conda packages with pip packages. And this is something that comes in really handy if you want to start leveraging more conda packages down the stream. And now we want to run the project. What we really just need to do is type one command on the terminal, RCC run, where we are in the folder of the project. And here's what's going to happen. It runs. So, and before it runs, it goes through your dependencies and actually installs them on the fly. The first time you're going to run this, it'll take a while. So it's gonna gather all the dependencies, install them, and make sure that you're all set to run, and then it will run. But what it does with the dependencies is actually caches them in a way that's pretty smart. So if you're already using some libraries that are located on other RCC caches, it's going to reuse those. So you don't need to every time download everything that you need just for one virtual environment. You can use cache that's existing in other RCC environments. And now basically you're all set to share and distribute your robot. That's how easy it is. RCC create, RCC run, and then you can use either RCC robot wrap as a command to create the zip file for all the project files and distribute that directly, or you then can just share it on GitHub and point RCC to use that when you need to run it. And obviously the template that we showed was a bit basic, so it didn't have anything else than just 3 files. So your typical larger project will have something like Python libraries, keyword files, and variables. So that's what the extended template is for. That allows you to create a project structure that comes with all the best practices that you'd expect in a Robot Framework project to be included. And so now that I'd like to actually, when I've gotten to know RCC a bit, I'd like to use it to run a robot that somebody else has built. So we at RoboCorp, we have this site called Portal where we collect a lot of these useful robots, or just examples, things that might be fun for others to run and try and sample out. We're going to expand on this index here, and you're going to be able to share your robots here in the future as well. Or you can just go on GitHub, find any project that's built and packaged with RCC, and you'll be able to run it directly. But let's pick something from Portal directly. I'm going to pick a Twitter web scraper robot, and here we have the command that I need to run in order to make it work. So it's going to be RCC pool and then the URL of the robot. So here I'm launching the video, and we are really using 2 commands. First RCC pool, and then cd into the folder and RCC run. It's going to again go through dependencies, check that everything is in place, and then run the robot, which is going to go through RoboCorp Twitter account and see what the first 3 Twitter posts are and pick the pictures and text from there. And that's just part of the things that RCC can do for you. And that's what's on the surface. If you just type RCC, you're going to see a host of commands available for you. Some of these are more cryptic than others. They are used mostly inside tools that leverage RCC, to build developer experience and things like such. And then in the bottom, you're going to have easy to use CLI commands, things like create, help, pull, run, tutorial, version. These are something that are meant for the human user to use in their day-to-day work. And looking into some of the under the hood capabilities for RCC, as I mentioned earlier, it comes with caching and compressing of environments. So it has a mechanism for reducing redundancy in cached environments that it pulls down and stores locally. And in one use case example, we use RCC obviously internally at RoboCorp in a lot of our projects, and we had a cloud environment that had 10 large Python environments for RPA projects, and those 10 environments consumed altogether 9 gigabytes of data. And then we compare it to a situation where we actually had 200 environments which were cached and compressed with RCC, and they fit in under 7 gigabytes of data. So that's pretty significant. Obviously, what's happening here is the environments are sharing a lot of files, and RCC can pick it up and notice what files are shared and only download the ones that aren't available in other projects. And that's how you can essentially get into 7 gigabytes for 200 environments, where 10 environments used to take 9 gigabytes. And this is even if you're not running a cloud service for RPA, obviously this is useful for your CI and CD environments, where you might need to download a lot of packages, a lot of versions of packages, and run them across multiple projects. And obviously that's a situation where you can't create a global environment for all these projects. And then I alluded to this earlier already, that RCC can allow you to mix and match Conda and pip environments. We recommend always using Conda Forge wherever possible. It's just more faster, much more faster and more robust to work with. And it'll allow you to run across different architectures pretty seamlessly. And to do this, we use something called Micromamba internally in RCC. It's basically a C++ implementation of Miniconda, and it's much faster to operate even than Miniconda. And looking at the bigger picture of this stack, here's some applications for RCC that we use at RoboCorp. So in our tool chain, how we build software robots with Robot Framework Python and Python, we ship it and run it with RCC, and we have a container environment in the cloud that allows you to spin up an environment and run a bot there within seconds by using RCC. Then we leverage RCC in all of our developer tools like RoboCorp Lab and VS Code extension. If you download our VS Code extension, you're going to see a lot of features and functionality that are familiar to you from the command line RCC. So the VS Code extension, even though it's called RoboCorp Code, is something that anyone using Robot Framework to build projects should really look into, because it allows you to do pretty cool things without actually working too hard. And here, if you look at some of the features, we can see on the left there's actually a tab that shows you the project configuration that's based on your robot YAML file that you have in place. It shows my first robot and the default configuration. And let's run this video and show that we can actually set a breakpoint in our project. Just click debug and our project will run and hit a breakpoint here. And you can see all the variables and built-ins just by that. So you have robot YAML as a file to define the project, and Conda YAML as a file to define dependencies, and you can simply one-click run the project without having to go even to the terminal. And in this case, you can debug the project as well. I think that's pretty cool. So summarizing it, we showed why we need an open source stack for RPA in the first place. It allows you to create, run, and share Robot Framework-based RPA projects seamlessly. Then we introduced RCC and some of its capabilities, how it can manage dependencies, use templates to build projects, use standard files like Conda YAML, Robot YAML, to define dependencies and configuration. And then we showed how to use RCC to create and share a robot in just under a minute. And finally, we went through some of the cool applications that we built by using RCC. Thank you.
Hey, Antti. Welcome to RoboCon.
Hey, Joe.
Good to see you.
Thanks.
All right, let's get into it because we have a lot of questions. We had like 2 sessions of people asking questions all over the place. So, first question is from Sarv, wants to know, how well is Playwright compatible with RoboCorp?
So what was the question? How long has it been, or
How does Playwright work?
how does okay? So hi Sav. Playwright works great with RoboCorp through the Robot Framework browser library. We also include in the RPA framework stack as well. So I think it's rpa.browser.playwright that you need to include, but it works pretty awesome. We just recently used it on a customer demo, and it was pretty powerful. We did some NetSuite automation on top of that.
Nice. Next question was, can this be used for test cases as well, or is it just RPA specific?
So the open source stack that we have built is like use it any way you find it useful. So we don't limit that usage of the stuff that we have built for RoboCorp Cloud specifically. They are RPA use case focused, but specifically the topic of the talk, RCC, is something that I think everyone building on Robot Framework and any Python project app for that matter should look into. So it's a pretty powerful way to configure and control project environments. I'd say that if you're doing anything with Robot Framework, just go and play around with RCC, and you find some usage for it. We've seen it being used inside Jenkins projects and the likes.
Great. So we have a Slido question from Adam. Adam wants to know, can I add custom libraries or Robot Framework resources into this robot.yaml file?
Yeah, I mean, absolutely. The tool chain that we have, you can add any custom libraries and custom Python code and what have you into the project. As you create the project template, if you use RCC, the extended template is going to actually have everything already in the right place. You just can add custom Python libraries into it. It's the extended template will kind of show you how to do that.
Great. So Simon wants to know, can I override Robot Framework parameters when I call RCC on the command line?
Good question. I don't know the exact answer to that, so I'd need to refer to our RCC developer. Yeah. Maybe take a look at the command line help, and if you don't get an answer, ping us at the RoboCorp forum, or ask a question on GitHub, or then join our developer Slack to ask a question that way.
Next question is from Dave. Wants to know, how does RCC deal with shared resource file? In other words, what if I have multiple robots that leverage the same resources, example, libraries and resources? How does RCC deal with this?
That's an excellent question. I think the jury is still out a bit on what is the best convention of like sharing resources. You can do sub-modules on Git. I would probably personally do it that way, or handle it similarly. But that's something that we are also thinking internally. What's going to be the best convention out there to really build out your, let's say you're running a larger RPA operation, you want to set aside your company internal libraries and then leverage them in your projects. So you can certainly use sub modules for that, and then you obviously can publish them on Conda or on pip and use it there. I think that's a sort of a added hassle. So if you want to be, anyway, in case you want to be a bit more robust, just publish them on as pip, or then put them on a GitHub repo and use pip there. But I think we still need to figure out a way to kind of lower the friction on that point on our side as well.
Great. So Marcus wants to know, do I need to install Conda along with RCC?
No, you don't. You just install RCC. It's a standalone executable. It doesn't require anything. You get everything that you need to have just by that. Not even Python, not Conda, not anything else. It'll use Micromamba internally, which is a bit faster than something like Miniconda. So that's really the great part of the RCC. It's just you need to install this one binary. Windows, Linux, Mac works on all of them, and it'll handle the rest for you. So you can essentially use that as the starting point always, and then it'll figure out the rest and do it in a kind of efficient and optimal way.
Great. Next question is: does RCC work with PyCharm as well as with RS?
So we don't have a PyCharm plugin or extension for RCC specific commands yet. We have the Robot Framework language server extension for PyCharm that Fabio is going to have a talk about later, I think today. If you have a PyCharm workflow, I recommend using RCC on command line. It's really kind of good ergonomically that way as well. On the VS Code, we have the extension, RoboCop extension, that will bring on those RCC capabilities. And we don't know any timeline yet as of whether we're going to integrate RCC specifically to PyCharm. But I've seen that the LSP extension has been fairly popular. So if you have ideas or you absolutely want to see it there, send us a note.
I'm sure you get asked this question all the time: is how secure is the RoboCorp cloud? Will the test data be downloaded onto a remote server anytime?
Good question. Sure, we get asked that a ton. So RoboCorp Cloud, that operates on a public cloud multi-tenant fashion. So there is obviously designed to be secure from the ground up. So that's really number one design principle that we have. If you have any needs beyond, regulation, compliance, and so forth, we do have RoboCorp Cloud Enterprise that can be self-hosted or then deployed in a private cloud. But the basic principle is that if you use the multi-tenant cloud, the data is kept inside of your own account there. We encrypt it, and then for storing secrets, we have also KMS-based vault. So it's really secure that way. And also you can, as a developer, control what data gets sent into the cloud. So you have controls around that. But if you have, let's say, regulation needs, contact us and we'll set up RoboCorp Cloud Enterprise.
Great. So Marcus has a question. He wants to know, why is every single keyword in its own keyword section?
That's a convention that's probably in some of the examples, because we use also Jupyter Lab as well. So we'll have RoboCop Lab. You can go to robocop.com, I think it's /downloads, and download that. That's basically a Jupyter Lab based environment for building up Robot Framework based RPA routines. Is really good for somebody who's just coming into the ecosystem, just like single installer, batteries included, don't need anything else externally. That does run those keywords inside Jupyter Notebook cells. So every cell has to start with that definition, where there's settings, variables, keywords, and so forth. So I guess that convention just spills over to our examples then.
Great. So Simon wants to know, is there any technical differences between normal robot test and RPA, besides the fact that tests then become tasks? In both cases, you're automating and expecting something. I never got that point 100%.
Yeah, at the end of the day, right, you do the similar thing technically on the really the basic layer. So you use a particular application through some of the user interface layers or through APIs and whatever, and then kind of drive it to a certain state that you want it to have. In testing, you validate this functionality and try to break it. Maybe in RPA, you might have a bit of more error handling there, and then expect the robot to handle exceptions gracefully. So on that layer is fairly similar, but when it comes down to orchestrating and operating, there it actually takes a really different approach compared to testing. So running RPA operations on something like Jenkins really a bit of a different game. Then that's why we built RoboCop Cloud, to make it really seamless to run RPA workloads in an enterprise setting properly, without having to lean in on CI/CD from testing, for instance. But there are similarities, but then the operational model, how you report, how you trigger them, how you schedule them, so forth, that layer is a bit of a difference.
We're out of time for questions, but I want to do a quick lightning round. Just give me yes or no answer for these last two questions that are probably easy to answer. Is, can we add a debug point inside the method of imported Python library?
Good question. Yes, in the near-term future, I think we'll have to check the team about that, but that's definitely in our plans.
Can I use Playwright and Selenium libraries interchangeably for my .robot file?
Interchangeably, that's a loaded question. I choose either or, because they work with the browser differently.
Okay, awesome. Thanks so much, Antti. I really appreciate it. Awesome session. Again, a lot of things here. Thank you once again for being the platinum sponsor for day 2 and helping support Robot Framework with all you do at RoboCop as well. Appreciate it. Thank you so much.
Thank you. And I'm going to be on the speaker's corner for additional questions.
Absolutely. Awesome. Thanks again. Cheers.